In the stoichiometry and the limiting reagent lab, what you're going to do is you're going to mix sodium carbonate and calcium chloride, and you're going to form calcium carbonate, which is a solid, and sodium chloride. So the calcium carbonate is a solid. We can filter that out from the solution, and we can determine how much we actually made. So we can use this data to determine our limiting reagent and our percent yield. So your lab handout walks you through the procedure. You're going to mix the volumes that are given in the lab handout, and you're going to determine how much calcium carbonate you form. Now let's look at what you're going to do with that data. So the first question in your analysis question says which reagent was the limiting reagent in trial 1 and which was the limiting reagent in trial 2. So we need to calculate which of our reagents, the sodium carbonate or the calcium chloride, is going to be our limiting reagent. So let's walk through how we're going to do that for trial 1, and then I will let you do that on your own for trial 2. So in our first trial, if we look at what we're mixing, we're going to mix 20 milliliters of 0.5 molar calcium chloride. And you'll want to plug in your exact volume. So when you're measuring this out in lab, you don't have to get it right at 20. If it's 19.9 or 20.1, that's okay as long as you're pretty close to the 20. But you do need to plug in your exact volume. So we have 20 milliliters of 0.5 molar calcium chloride. And we know that molar means moles per liter, which means that we need to convert our milliliters to liters. So then, molar is moles per liter, so I'm going to put the liters on the bottom, and 0.5 moles per liter on the top. Now, I want to know how much calcium carbonate I'm going to form. So I need to convert to calcium carbonate. So if we look at our reaction, we have 1 mole of calcium chloride forms 1 mole of calcium carbonate, which is kind of nice when it's a 1-to-1. That makes a little less work for us. And then we need to know the molar mass of calcium carbonate. So calcium has a molar mass of 40.08. And if we look at the periodic table, carbon has a molar mass of 12.01. And then we know that oxygen has a molar mass of 16. So if we add that all up, we have a molar mass of 100.09 grams of calcium carbonate. So now we're going to put this in our calculator. So we're going to take 20 times 0.5 times 100.09, and we're going to divide that by 1,000. So make sure you're putting this in your calculator with me and see if you get the same thing that I do. So rounding to our correct number of significant figures, we get 1.00 grams of calcium carbonate. Now let's do this with the sodium carbonate and find out which one is our limiting reagent. So we're going to mix 10 milliliters of sodium carbonate. And again, we're given our concentration of molarity, which means that we'll need to convert our milliliters to liters. For 1 liter of, that should be 1 liter of sodium carbonate. And then we have a 1.5 molar solution, which means that I have 1.5 moles of sodium carbonate per liter. And then we want to know how much calcium carbonate we're going to form. So according to our reaction, 1 mole of sodium carbonate reacts, and we get 1 mole of calcium carbonate. And then we calculated our molar mass of calcium carbonate already. So we can use that number again. So go ahead and put this into your calculator. 10 milliliters, well, 10 times 1.5 times times 100.09 divided by 1,000, and put this into your calculator and see if you get the same answer I did. So rounding to the correct number of significant figures, I have 1.50 grams of calcium carbonate. So if we compare our two trials, or our two reagents here, the calcium chloride is going to make less calcium carbonate, which means it's going to be the limiting reagent in trial 1. So you're going to do the same calculation for trial 2, except you're going to use your volumes from trial 2. So I will let you do the calculation for trial 2 on your own. Question 2 asks you what is the theoretical yield of calcium carbonate in each trial. So your limiting reagent dictates what your theoretical yield is. So when we calculated which reagent was our limiting reagent, we also came up with our theoretical yield. Number 3 asks you for the percent yield, and it shows you in your lab handout, and we've talked about this in lecture, that percent yield is the actual yield over the theoretical yield. So you're going to take the actual yield that you get in lab and you're going to divide that by the answer you came up with in question 2. And then you have to discuss some possible sources of error in this experiment that would have caused a percent yield less than 100%. And then we're going to talk about some practical applications, and you're going to think about if you were the manager of a chemical manufacturing facility, why would it be useful to know which reagent would be the limiting reagent? How would you use that information? So those are some things for you to think about. So before you come to lab, make sure that you have read through the lab handout and that you have submitted your purpose and procedure on Canvas. And I will see you in lab.